Good morning, students. In this session, I'm going to explain the rest of the types of operating systems. Previous class, we have discussed what is operating system and some basic details regarding operating system. And coming for the types of operating system, I have explained only one type of operating system, which is batch operating system. So the rest of the things that we are going to discuss is like what is multi-programmed operating system, what is time-sharing operating system, what is multiprocessor operating system, real-time operating system, distributed operating system, and clustered operating system. So we are going to discuss these types of operating system in this session. First, coming for multi-programmed operating system. So multi-programmed operating system, in the sense, these operating systems are built to process more than one program at a time. Okay, I told you what is a program and what is a process in the previous session. Any set of instructions will consider it as a program, and if you want to convert that into a process, that program has to be loaded into the memory. When that program is loaded onto the memory, it will act as a process. Okay, so when it is acting as a process, so that is nothing but, if I consider simply an example of, I have installed a software called as VLC player. VLC player, if it is a software, if it is installed into your hard disk, and if you want to use that software, whenever you want to use that software, this software has to be loaded onto the RAM, onto your primary memory. Once it is loaded onto the primary memory, this particular memory, which is nothing but RAM, will contain all the programs or process, that is, or the program list of programs which can be executed. That programs will consider it as jobs. Okay, job is nothing but simply a program, so that is waiting for execution. So how it will get executed? When the CPU or your processor selects that particular program, and it will be starting executing that particular program, so then it will convert into process. Okay, so now whenever you consider RAM is a primary memory, and I told you in every system will have the basic operating system will be acting as your first program that will be starting. So whenever you're starting your computer, one program that will be running throughout your computer until your computer is switched off, that is nothing but your operating system. So once you switch on your computer, operating system will be loaded onto the RAM, that will be executed by your CPU. And if you want to execute another program, say VLC player, so that program will consider it as one job or one program that I want to execute. Similarly, if I want to execute MS Word, so I'll write Word, that will be second job number 2. So like this, I can have any number of jobs that will be stored on the RAM. Now, if this wants to be executed, it will be executed by your CPU. CPU is the device or your processor which will be executing each and every program that you load onto the RAM. When it is being executed, it is called as what? Process. So when program is converted to process, any program under execution will consider it as process. So whenever you want to execute any program, that program has to be loaded onto the RAM, and the CPU will select one program and it will execute that particular program. So this process will consider it as your execution process. This is how your execution will be done. Now when you consider multi-programmed operating system, in the sense, this operating system will support so that more than one program can be loaded onto the RAM. Onto the RAM, you can load more than one program, and your CPU will execute each and every program. How it is going to execute? It is going to execute by the concept called as switching. Okay, it is going to execute the programs or jobs in terms of the concept called as switching. Now what is switching? Switching is nothing but when your CPU is executing one say VLC player, it is executing VLC player. If it is executing VLC player, it has loaded the song, it has started playing the song. and whenever it is idle or whenever this program is not using CPU, the CPU what it will do, it will select the other program for execution. So whenever the given program is not using the CPU, instead of wasting the idle time of the CPU will be selecting other program for execution. This process will consider as switching. Switching is a method where we have if we have more than one program to be executed, if we select or the CPU selects one program instead of the other program for execution, that process is nothing but your switching. So it is nothing but we're going to select say we're going to stop one program and we're going to start executing the other program. So in that case we'll consider it as switching. This switching is done by a device or a concept called as CPU scheduler. Okay, CPU scheduler is the concept of selecting which device or which program to be executed. Now you can see scheduler is nothing but it is going to tell the CPU which program to be executed and which program not to be executed. So that is done with the help of this concept called as CPU scheduling, where it will select any one program for execution, so where the other program will be waiting in the RAM. Okay, so this is this type of operating system will consider it as multi-program operating system, where you can store more than one program onto the RAM and the CPU is going to select any one program for execution. What are the advantages? It is going to reduce the idle time of your CPU. Idle time is if the CPU should not be empty, it should be executing something. So if to reduce that idle time, so we'll be using this concept called as switching, so that whenever one program is waiting for some function, so the CPU can execute the other program. Okay, so that is how this is about the concept called as switching. Next, coming for time sharing. Time sharing is when you are executing any program, so the CPU what it is going to use is it is going to fix some time for each and every programs. Suppose I have this same example, I have this programs like say VLC player, MS Word and other different types of programs, and I have only one CPU. And I have a list of programs to be executed. In this case, what the thing will do is time sharing, in the sense, suppose 5 milliseconds of time will be spent on one software or one program, and that is nothing but 5 milliseconds it is going to execute VLC player. Next 5 milliseconds it is going to execute MS Word. So like that it is going to split the given time or CPU time, so with the other a list of programs also. So when it is splitting the time or allotting the time for each and every programs to execution, that type of operating system will consider as time sharing operating system. Time sharing operating system is an operating system where the CPU will be allotted with some time lapse. So that time lapse according to which it is going to execute each and every program for some limited amount of time. So after the execution of that particular time period, it is going to select the other program for execution. So like that it is going to switch from one program to other program, which will make or which will increase the efficiency of the CPU, where it will be giving more response to the user, so that it can increase the performance of the CPU. Okay, so that is the thing about what is time sharing operating system. Next, coming for what is multi-core or multi-processor operating system. Multi-processor operating system, in the sense, so you have heard about something called as dual core, quad core, and you have heard about what is octa core, and you may have also heard about what is hexa core. Okay, what are these is nothing but whenever you consider any CPU or your processor, this microprocessor is a device that will have these things. Like if it is having two CPUs in a microprocessor, then it is considered as dual core. If a CPU is having if a microprocessor is having 4 CPUs, then it is called as quad core. Similarly, if it is having 8 cores, then it is called as octa core. 6 in the sense it is called, we are going to call it as hexacore. So that is nothing but in a single microprocessor we are going to have these many number of CPUs, where each and every CPU will be capable of executing individual programs separately. So this type of representation will consider it as multiprocessor operating system. Multiprocessor operating system is an operating system where we'll have more than one CPUs in a given processor, which will be able to execute more than one task at a time, which will be like, we'll consider it as multitasking. Okay, when I say multitasking, so if one processor is executing OS, other process will be executing VLC player, and the other process will be executing MS Word. Like that, we are going to have multiple programs or multiple tasks or jobs will be executed simultaneously by your CPU. This type of operating system will consider it as multiprocessor operating system. Okay, so after this, next we'll come across what is real-time operating system. So when I say real-time operating system, it is based on time constraint. Okay, so it is based on some time constraint. Okay, so when I say time constraint, it is nothing but it is just like for any function or any jobs to be functioned or processed, we are going to fix some time limit for it. Within that time, it has to be executed. If it is not executed, we are going to select the other process, or we are going to switch from one process to other process. It is just like we can consider it as any kind of online transactions. So the online transactions, what we are going to do, those kind of online transactions will consider it as real time. So real time in the sense, within we will have short amount of time for response as well as request. For any request and for any response to be processed, we'll have short amount of time, or we'll have a time constraint. Within the time constraint, the functions has to be executed. Example, like your online transactions, I can say your banking transactions. Whenever you are using any kind of banking functions, so in that case, you'll have some time limit. If you exceed that time limit, the banking application what you're going to use, it is going to be logged out. Okay, so these type of functions will consider it as real-time operating, which will be using real-time operating system. So which will have some time constraint. Based on the time constraint, it is going to execute the instructions. If it is not given the request or response within the given time constraint, it is going to stop that process there. Okay, so which is like your real-time operating system. And coming for distributed operating system. So distributed operating system is like your network-based technology. Network-based technology, I'll just discuss a few concepts in this network-based technology. First is, we have two things. One is called as client, other is like your server. Okay, so example, say I want to search any information regarding operating system. So I want to search an information regarding operating system in the internet. So on the internet, I want to search some information regarding operating system. In that case, the person who will be searching will consider it as client. Either it may be a computer, either it may be mobile or something. Any device through which you are trying to search will be acting as a client. That information will be sent to the network. Okay, from network, it is going to send the information to server. Okay, so this servers will be connected to the file locations or your source. You'll have different things. Okay, so in the sense, whenever I type operating system, if you are connected to the internet, that information will go to the server. So client is the device that is requesting for the information, and server is the device which is providing the information. so which provides the information that device will consider as server, and the device which is requesting for the information will be acting as a client. So when I request for the information in the server, it is going to search for that particular information stored in its database or in its file server or other location. So this is how your distributed operating system is going to work. Whenever you consider distributed operating system will have the concept like client and server, where one device will be requesting for the information, other device will be providing the information. What are the advantages? Advantages is like, so you can share the data faster, because if I'm 2 or more devices or 100 devices are asking for the information, if 100 devices are asking for the information, simultaneously it can connect to the network and it will connect to the server, and I can access the information from the database or your data source from data center. I can access the information. So these are helpful, or these are the things that is like your data will be shared faster. It can be stored in more than one place, so you'll have reliable information, that is you can use it for long term. So these are the things that will happen when you are using distributed operating system, where you'll have client, server, and it will be based on network, where the information will be stored in separate place and client can request the information whenever it is required. And at last, coming for clustered operating system. Clustered operating system is like if you have suppose I have three computers connected to one another. Okay, so if this will form a LAN. LAN is nothing but local area network. Local area network is like within a building or within a within a room. If I connect one computer with the other computer, then it will form a network, which is like your local area network. So in this local area network, what is the concept of clustered operating system is? Clustered operating system will act something like, if one device is being used and other device will be in the idle state, okay, or it will be like your backup. Okay, so backup in the sense, if this system is crashed, we are going to use this system which will have all the data. Okay, it is like when you have more than one devices that is connected through a network, it will form a LAN. So in this case, what happens, if you have more than one device, these devices, what will happen, what is the use of these devices? Suppose if there is any crash or if there is any failure of one device, the data whatever you are having will not be lost. We'll be storing that data in more than one device, so that even though if one device is getting crashed, the data will be available in other device and it can be retrieved the data. This type of operating system which will be used for building these type of computers will consider as clustered operating system. So it will contain again two things. One is like asynchronous, another one is synchronous. When I say synchronous, so all the systems will be working at the same time. Okay, so asynchronous is if one device is working, other device will be in idle state. Based on this failure, on the failure of this first system, we are going to use the second system. This type of representation or this type of operating system will consider as synchronous or clustered operating system. In asynchronous, everything will be working at the same time. In synchronous, only one will be working. So if based on the failure of the first system, the second system will start executing or you can use the second system, where you will not have any loss of data. Okay. Hope this is clear about what are the types of operating system. So we are going to discuss next concept, which is what is functions of operating system in the same chapter, and after that we have system calls. So if we finish those two topics, we can complete with your first chapter regarding what is operating system and other details. Okay, am I clear with this topic, which is types of operating system?